Hey everyone, I hope you're doing good. I'm going to go ahead and go over with you two types of conversions here. I'm going to go over the mole to particle ones, the simple ones, and then I'm also going to go over how to do and back, of course. And then I'm also going to go ahead at the second part of the video to go ahead and do mole to mass and mass to mole. So I'll cover both those in this video. Feel free to skip to the parts that you need the most. Okay. So really quickly here. So remember, as an equivalency statement, 6.022 times 10^23 particles equals 1 mole. And this could be 1 mole of anything. Okay. It could be remember, a mole is like a dozen, right? It counts. So like I could have 24 eggs and that'd be 2 dozen, right? So a mole is 6.022 times 10^23 of something. And what it is specifically useful for is, like, if you look on the periodic table here is, we'll take iron, right? Iron, if you look at the bottom, iron has a mass of 55.8. So if you have 6.022 times 10 to the 23rd atoms of iron, that pile of iron is going to weigh that much. And if you have 6.022 times 10 to the 23rd atoms of beryllium in a pile, they're going to weigh this much. So if you have a pile or a grouping of that many atoms, they equal the number in the periodic table. And that's where that number came from. Okay. So we're going to go ahead and do a few different conversion problems. I think I'll start with just 2 and 3 here. 23.4 times 10 to the negative 3. Okay. 23. Oh, it's doing the video. We'll try again. Okay. Here we go. 23.4. 20. Actually, I could have done it this way. Okay. 23.4 times 10 to the negative 3 CaCl2. There we go. Okay. Cool. So we are going to, and that is, was that moles or particles? Let me figure out here. So 1 second. Boom, boom. Those are the moles. Those are moles. And we're going to go to number of molecules, which is the particles. Okay, so you take the 23.4 times 10 to the negative 3 moles CaCl2. And you need to get rid of the moles CaCl2 first. You need to get rid of moles CaCl2. So moles divided by moles, okay? And you're going to molecules. CaCl2, okay? And the number you're going to use here will always be 1 mole, almost always a 1 in front of moles. And that's going to be equal to 6.022 times 10 to the 23rd molecules. Okay. So since it's on top, you're going to multiply. Okay. So there's several different ways you could do it. You could just do the front numbers, which is fine. You could do all sorts of different ways. I'm just going to enter it straight in my calculator here. So I'm going to go up here. I'm going to go 23.4. Okay. Then I'm going to hit this EE button, and that gives me the exponent. And then I can go -3 for my exponent. And I'm going to go ahead and multiply that times 6.022. And then I'll hit the EE button again. And then I'll go 23 for the exponent 10 to the 23rd. Okay. And it comes out for me at, looks like we need 3 sig figs. So mine comes out longer. It comes out 1.409, blah, blah, blah. But I'm going to run at 3 sig figs, which would be 1.41. Okay. And then the exponent is times 10 to the 22. Okay. So given that, it looks like that's my number of molecules, CaCl2. So hopefully that helped. Okay, I'm going to go ahead and clear screen. We'll do one more like that. We'll go ahead and do something about maybe or something like So we'll go ahead and do this ducks one. 3.4. So it'll be 3.4 times 10 to the negative 20 moles of ducks. And we're going to go to ducks themselves. Okay. So I'll go ahead and here go like that. On the bottom, I'll put moles of ducks because I want to get rid of that. And I'm going to go to just ducks. How many ducks do I actually have? So just like dozen, 1 mole of something is always going to equal 6.022 times 10 to the 23rd of that item. Okay. So now, again, you could just, if you want to, that's all on top. So you could go ahead and multiply front number times front number, and then you could add the exponents, negative 20 plus 23. That all works great. You get the same exact answer. Or you can just enter it in your magic calculator, 3.4. Then I hit the EE button, negative 20. Okay. And then I'm going to multiply that times 6.022, hit my EE button, and go 23, and it comes out as really long number here, 20474.8. So it looks like I need 2 sig figs. Okay, so I'm going to keep the 2 and the O. Okay, I'm going to 1 spot, 2 spot, 3 spot, 4 spots. So it'll be 2.0 times 10. Now the question is it really big or small? It's a big number, so I can go times 10 to the 4, positive 4, and it looks like ducks is what I end up with. So it looks like it's about 20,000 ducks-ish, but or 2.0 times 10 to the 4 ducks. Hopefully that helped one direction there. I'm now going to go ahead and do the other direction. Give me a second. I'm going to go ahead and wipe the screen. Cool. So we're going to go ahead and do 4 and 5. I'm going to kind of ignore the other ones for now. So we'll do, we're going to start with 200.0 times 10 to the 25th atoms. And that's aluminum. And then we're going to move towards moles because that's what we want to find, moles here. Okay. Oh, I wrote that in a weird spot. Oops. Okay. Anyway, it'll work out. Okay. Railroad it. Okay, and I'm going to get rid of, notice here, atoms are on top, so atoms need to be in the bottom. That lets me take atoms and divide them by atoms. And then I can go to moles of aluminum. Okay, so now you have to remember where things go. So for example, 1 is almost always in front of moles, and atoms or whatever type of particle it is, molecules or otherwise, you get the 6.022 number times 10. Okay. So in this case here, notice we're dividing. And you could take front numbers and go front number divided by front number, which works fine, and then subtract exponents, subtract. So you go 25 minus 23. That worked. Or you can enter in your calculator, which is what I'm going to do here, 200. Then I'll hit the E button, 25. Then I can go ahead and divide it by 6.022. Hit my E button, 23. And it looks like it comes out at 3,321. And then it keeps going as 0.1, 0.16, or well, it goes 1.5. But either way, it looks like I have 4 sig figs is what I want. So it's going to come out being 3.321 after I shifted over 1 to 3 spots. And then it'll be times 10 to the 3rd because I moved it 3 spots. This is a big number, so positive exponents. Final unit, don't forget it, is moles AL, because it's a common mistake, forgetting your unit. And that should be your final answer. Remember, if you have this top one and the unit, that would also be fine. So assuming it's clear, mine's kind of messy now, but you get the idea. So there you go. We'll do one more like that, and then we'll move into the mass problems. Okay, second. Okay. This one here is how many moles, and you're gonna start with 1 atom of calcium. And we're going to go towards moles. So 1 atom of calcium, and we're going to head towards moles. So we're going to get rid of atoms of calcium. Atom of calcium. And we're going to go towards moles of calcium. Okay, small a. Okay, so remember the 1 almost always goes in front, and I put atoms in the bottom, so we go atoms divided by atoms, cancel it out, right? 1 always goes in front of the mole, and this one would be the 6.022. Doesn't look like I left myself enough space, but I'll see if I can jam it in there. Okay, so we're dividing. So it is 1 divided by that horrible number. So let's see what we get out of here, okay? So 1 divided by 6.022 E23. Get my there. And it looks like I end up with how many sig figs? It looks like just 1. So I end up with 1.66 here, right? But I'm going to round that off just to a 2, okay? Because it's only 1 sig fig, right? 2 times 10 to the negative 24. And then it looks like it's moles calcium, which makes sense. I mean, if you think about it, 1 atom should be like almost no moles because you need a ton of atoms to add up to a mole. So 1 atom should be like almost no moles, right? So that's why it's such tiny. Okay, so I'm now going to go ahead and transition here from this one to the mass ones, and we'll go ahead and do a couple mass problems here. 2, maybe. Okay, so really briefly. For these, instead of before where it was 1 mole equaling a certain number of particles, now it's going to equal the number on the periodic table in mass. This is the periodic table number. Okay, so you look on the periodic table and you find the mass number on the periodic table. And so for aluminum, you'd look up and you'd see, what is it, 26.9 something. And then I'd go look up BE would be 9.01. You get the idea. It's the mass number at the bottom, okay? And that equals, those always equal 1 mole. Okay, so that's what we're going to be using for these problems here. So, okay, let's go ahead and we'll do the first one here. I'll jump around a little bit. We'll do the first one, and then I'll do one on the next page too. So we're going to start here with 6.94 grams of lithium. And as always, a railroad. You'll put grams lithium on the bottom because that's what you're trying to get rid of. Grams lithium divided by, we're going to go to moles. We'll go to moles lithium, okay? Where do you find the numbers? The periodic table, okay? So I look up here and I find lithium, and lithium mass is 6.9 something. Now, I notice up here I have 3 sig figs, so I need to have at least 3 sig figs. So it's going to be 6.941. If I took 1, I like to keep 1 extra, just for rounding purposes or whatever, just in case I screw that up. So, but yeah, you get the idea. And then 1 almost always goes in front of moles. So 1 goes in front of moles, and then the 6 point whatever right there. So you can kind of get the gist of it. 6.94 divided by 6.94 is equal to 1. What a surprise! But it should be 1.00 because it's 3 sig figs, and then it'd be moles lithium for that answer. Okay. Now, what we're going to do here is we'll go ahead and I'm going to skip to another problem that's a little bit harder. Okay, I'll go to one on the next page. Okay, so we're going to go 5.41, this many grams of oxygen, 2 moles. So the same direction, okay? So I'll start over here with 5.41 times 10 to the 3rd grams oxygen. Again, whatever you start with, you'll have to get out. So you get rid of grams of oxygen, and you'll go to moles oxygen. Okay. So in this way, it looks like grams oxygen. If you look on the periodic table, there's some rounding I can do. If I did it, it would end up being 16.0 or 16.00. Either way is rounded correctly. And that's equal to 1 mole. So, I forgot the 10 to the 3rd. You don't want to forget that. So I could enter my calculator. Notice we're dividing this time. So I'd go 5.41. I'd use the EEE button to get in my calculator. So times 10 to the third. And then I'm going to divide it by 16. Okay. And it looks like my answer is 338 and some change, but I only need 3 sig figs. So I'll stop at the 338. I don't need to round it up to 1 because I don't see it, but there's a 1 after it. So I don't need to round it up. Now, if I want to go scientific notation, I'd make it 3.38. So I'd move it 1 spot, 2 spots, and I make it times 10. Okay. So 1, 2 spots. Okay. And I almost, no, I didn't. So we're all good here. And I moved 2 spots. So it'd be 10 to the 2. And then needs to be moles oxygen. Can't forget that stuff. Now, if you did 338 moles oxygen, that's right, or 338.1 or whatever moles oxygen, that's also right. This one on the right side here is the one that would give you the extra credit. Okay. So let's go ahead and do some of the other direction here. Okay. Okay. Let's move the other direction. So I want to go and do this top one here. 2.4 moles calcium. And I'm going to try to get to mass. And remember, mass is grams. So I'll get rid of moles calcium. And I'm going to go to grams calcium. Okay. I'd look up calcium in the periodic table. It looks like it's 40. I'd ask myself, does it go on the top? Does it go on the bottom? And remember, that always goes in front of grams because that's what it is. The number in the periodic table is a grams number, 0, 8. That's way too many. I only needed 2. I put 4 down. For safety, I would put down 3, but yeah, you get the idea. And the 1 almost always goes here. I apparently way overdid it. So in this case, notice I'm multiplying. So I go here 2.4 and I'd multiply it times 40.08 or whatever. Even if you have less, you'll see it rounds off to pretty much the same number. And it's going to end up being, looks like 96. And I have 0.16 here, or 19. So I put 19. I still need to round it to 2 sig figs. So it's going to round off to 96. So if you only did 40 here, you probably will round off to the same point and get the 96. It could also be 9.6 times 10 to the 1. Okay. And then it is grams calcium. Okay. That's kind of how that one works. We'll go ahead and do one more practice problem here. Okay. I'll do the hard one on the next page. This one is harder than I'm going to probably ask you to do most of the time. Okay. So let's go ahead and take a look at this. And it's going to go from kilograms, and we need to go to moles. So you can know how to go from kilograms to grams. We also know how to go from grams to moles. Okay. So it's going to be a 2-stepper. So let's go ahead and lay this out. 3.2 times 10 to the 2 moles. Oh, I'm sorry. I have it backwards. Let me erase it here. Eraser. My plan is backwards. So let's do it right. Okay, here we go. So I start with moles. So I'm going to go from moles to grams, and then I can go from grams to kilograms. That's how that's going to work. Okay, so this is sodium. So it's going to be Na. So we'll get rid of moles, and we'll go to grams of Na. Cool. You look up on the periodic table the mass of Na, which is sodium, and it looks like I need 2 sig figs. Well, I'll give myself 3, which would be 23.0. Now, you might be like, it shouldn't be 22.9. You round up, it's 23.0. Take a look at it. Okay. And there's the 1 here. Okay. That gets rid of moles. So we're done with moles. Now we have grams. So we need to get rid of grams Na. Okay. And we're going to go to kilograms Na. Okay. You look up kilograms on the table before. Kilograms is 10 to the 3rd. Remember that always goes in front of the base one. So there's 10 to the 3 on the bottom and 1 on the top. Okay. So how do I enter that? Well, my calculator, I would go 3.2 and I would go my EE button, and I have the exponent. Looks like I'm going to multiply times 23 times 23. Okay. Then I'm going to divide. How do you enter the 10 to the third? Well, you can go 1, and then you can go EE, and then you can go the 3. So you have to put the 1 in front. Okay. And it looks like after I get that whole big long thing, it's going to end up being my answer as 7.36. Okay. Looks like I need 2 sig figs, so I might round it to 7.4. And then it's going to be kilograms of Na. Okay. That is a harder problem. That is more like an extra credit style one that I might do on the quiz or something like that. So that's there for you. If you need help, thank you guys very much.